Okay, here's the homework for this week's Suvat questions. So if we look at part A, we were given a velocity time graph and we need to find the acceleration of the train at t equals 10 and t equals 420. So to start with, if we write Suvat, we can then start to fill in all the information that we know. Now in the first instance, at t equals 10, this is on this part of the journey here. We can see that the train had constant acceleration all the way through there, so no matter where you calculate the acceleration, it will always be the same. So we could actually say that t would be 30, u would be 5, v would be 20, and a is what we were calculating, and we can use v equals u plus at. So therefore 20 is equal to 5 plus 30a, so 15 is equal to 30a, so 0.5 meters per second is a. That's ms to the minus 2. I noticed there were a lot of units missing there as well. For part B, for the second part of that, at t equals 420, well, that was quite straightforward, because if you notice, 420 is just about here, and this is where the velocity was constant at 20 meters per second. So at t equals 420, there was no acceleration, so a was 0. Okay, then for part B, well, if you check, find the velocity at t equals 20. Well, now we know what the acceleration is, we can sub in our values. So if we write Suvat again, we've got a, we now know is 0.5, t is 20, u was 5, and we want v. So again, it's v equals u plus at. So v is equal to 5 plus 0.5 times 20. So v is equal to 5 plus 10. So v is 15 meters per second. So that's the first two parts, A and B, complete. Now for part C, it says calculate the distance travelled from t equals 0 to t equals 480. So that's basically the whole journey. And we know from a VT graph that the whole journey is given by the distance under the graph. So what we've got here is we've got three parts. We've got A, B, and C. So if we start looking at part A, well, that's a trapezium. And remember, trapezium is the sum of the parallel lines halved times the height. So for A, we're going to have 5 plus 20 over 2 times by 30. For B, it's basically just a rectangle. So it's going to be the difference between 430 and 30, which is 400, multiplied by 20. And for C, it's a triangle. Base times height divided by 2. And if we look at the base, from 430 to 480, that's 50, and the height is 20. So that's going to be 50 times 20 divided by 2. So if we work out each individual part, starting with A, well, a half of 5 plus 20 is 12.5 times 30 will give you 375 meters. 400 times 20 will give you 8,000 meters. And half of 20, 50 times 20 over 2 will give you 500 meters. So the total journey time is the sum of all those, which should have given you 8,875 meters. So that was the answer to the first part. The big mistakes came from not realizing that this was constant acceleration here, and miscalculations of the trapeziums and the triangles. Okay, so you might want to check back through that when you get your homework back tomorrow.